we have a very nice geometry problem. So what it says that find the largest area of the rectangle, find the largest area of the rectangle that can be cut from a right triangular shape of paper that has two sides, uh, 12 centimeters and 20 centimeters. So you have a right triangular shape paper. So when you look at this problem, so let's try to for these problems actually you definitely need to like kind of draw the situation. So we have a right triangular uh, sheet of paper, and then the two sides, and this is right triangle, is 90-degree, and then the two sides are 20 and 12. Now you may wonder why this question is not obvious. So for example, you can see you can have a triangle rectangle like this, or you can have a rectangle like that, or you can even have a rectangle like this, like a really tiny uh, vertical one, and like that. So you can see, so you can have different areas in each time. So, and it can change depending on how you're gonna consider that. So that, so you can see that this problem is not obvious. You can get different areas, different time. So that's why like we need to use calculus to answer the question. So let's see how we can do the problem. So first we're gonna draw it, two sides, and it's not drawn to a scale. So and then what we do, so we have the rectangle here, so we just pick like a random rectangle. So this one, so that's the part you're gonna cut off, and then we know those sides. So 20 and 12, and it doesn't matter which side you pick as 20, you get the same answer. So now what we can do, I'm gonna pick this side, the length of the rectangle is x, and then when you do that, you can see this remaining part, so it's be 12 minus x, and then let's call the width of the rectangle y. So this it's going to be x, and this is going to be y. So that means here this part going to be, since it's all together 20, so it's be 20 minus y. So those are the geometries that you're gonna get from this one. So what you want to do is to maximize this area. So for what values you get the maximum area. So it's like a simple calculus problem. So let's say so this is an important part, let x be the length and y be the height of the rectangle. So x is the length of the rectangle and y is the width of the rectangle. Now what we do, we use similar triangles. So you can see that there are a lot of similar triangles. We can use these two. We can use this small triangle and the large one. So large one means the original one. So we can say by similar triangles. So by similar triangles, you can say, so what we normally do, we're gonna write the one that we need as the top one. So we're gonna say y divided by, you can say 20, so that's the corresponding one on the big one, and then from the small one you can say 12 minus x, so the corresponding one would be 12. So y corresponds to, so you can see y corresponds to the major one, and then 12 minus x corresponds to the long side, and then that's what you get. Now what we're going to do, we're going to simplify this one. So how we do it, we can multiply by 20 both sides. So you can write this one as y equal, if you multiply by 20, so 20 over 12, and then you have 12 minus x, that's what you get. And then you can also simplify this a little bit. So you can see, you can the 4 is a common factor, so you can write this one as 5 third 12 minus x. Okay, so we find y in terms of x, so it will be useful later. Now what we can do, we can have the objective function. So in this case the area, so we know that the area is simply the length times width. So length times width, so let's substitute here. So that means the x times, that's the length, width is y. So if you want, you can write that first. So you can say x times y, and then let's plug in. So which is x times y, we solve that. So we got that as times 5 third x minus 12. So that's what you get. Now what we can do, we can simplify this a little bit. I mean, you cannot do much. So you can do 5 third, you can write it in front and then say x times x minus 12. So we can write it like that. Or actually you can distribute this one. Both forms are useful. Sometimes when you want to plug in numbers, the factored form will be useful. But when you take the derivatives, the expanded version would be useful. So we can write both, so it can be useful. So it's the x squared minus 12x. That's what you get as the expanded one. So now your actual question would be maximize. So you can say maximize. So that's the actual question. So maximize the function a. We can call this function a, ax, 5 third x squared minus 12x on what interval? So you can see mathematically the smallest value that x can take is 0. What's the largest value? You can see, since according to the drawing, you can see the largest value of x can be 12. So if you do the other way, then the largest value would be 20. Depending on what you draw, so you can just use that. Okay, so that's the problem. You have to maximize this function on the interval 0 to 12. So we can use calculus for that. And you can see that this is like a parabola. So you can just use the the properties of parabola. The axis of symmetric axis. We know that always the maximum happen on the axis of symmetry. So x equal negative b over 2a. So that's like another approach. If you want to do this without using calculators, you can do that. It's b over 2a. So if you plug in the values, that's going to give you the actual maximum or minimum value. So and this is like, this has a minimum. This, because it's like it's gonna go. So and you may see that there's an error, because if it is the case, you can see that there's a for this one there's a minimum, because it's like a concave up parabola. So what happened here is, you can see we put the wrong one, because what we have is 12 minus x, not like x minus 12. So we're gonna fix it. So this will be x minus 12, actually 12 minus x. So we're gonna change this, because you notice that there's an error, because it cannot be. If it is the case, then you get a completely incorrect answer. So it'll be 12 minus x. So this is 12 minus x. So this will be 12x minus x squared. Now it's good. So this is also 12x minus x squared. The reason is, you can see that now this is upside down parabola. So if it's upside down parabola, you can see you get something like that. So that's the benefit of checking that. So now we see that that's the axis of symmetry. That's what we are talking about. So the maximum happened there. The value you can get from this formula. Okay, so that's the idea. So now let's try to use calculus to finalize the problem. Actually, this is the x value here. So, and then you get the maximum over there. So that's the maximum x. Yeah, but this is like how you use parabola, properties of parabola to solve it. So let's use the calculus now. So first we take the derivative. So it is a prime x. So which is 5 third and 12 minus 2x. And then we set this equal to 0. And then we can solve for that. And you can see that you can ignore this, is just a factor. You can ignore that. So you're going to get 12 minus 2x equals 0. So that means you can see clearly x equals 6 is the answer. So that's the critical point. So you get the critical point. Now we really don't know whether it's a maximum or minimum according to calculus. So what we need to do is look at the second derivative. So if you look at the second derivative, a double prime x, and you can see that which is negative. So you can see if you write all these steps, so what will happen is you just multiply by negative 2. So you're going to get, so that means it is negative 10 over 3. So which is negative. So that means even at the critical point, because for any x which is negative, for any x, so that means for even at the critical point you get the negative sign. That means since the negative has a maximum, so has a maximum uh, due to the second derivative test. So you have to do that because otherwise we don't know. Critical point, just a critical point doesn't say anything. So now we know that has a maximum, and this is a one critical point situation. Since this is one critical point, this maximum has to be absolute maximum. So we know that, okay? So we can write this one, since there is, otherwise we cannot say that, since, because it can be at a endpoint, but because since this one has only one critical point, this local maximum becomes a absolute maximum. Since there is only one critical point, only one critical point, there is an absolute maximum at x equals 6. Okay, so now what we can do, we can find the corresponding y. So we can see when x equal, we normally do that after we justify this one, because otherwise you can waste time if there are multiple points. So when x equals 6, y equal, we can say is 5/3 12 minus x. So that means it is 5/3 12 minus 6. So you're going to get that 10. So 10 is the corresponding y value. So now we can write the area. So that means the area, so the maximum area is, you can see it is x times y, it's a rectangle. So it is 6 centimeters times 10 centimeters, which is 60 centimeters. So 60 centimeters squared is the largest area possible. So we can write finally the largest, you have to write that the largest area is 60 centimeters when the rectangle has the dimensions, when the rectangle has the dimension has the dimension 6 centimeters and 10 centimeters. Okay, that's how we complete the problem. Again, this is a very important observation, because you can see that we did not check the endpoints. We don't have to check the endpoints if we observe this one. So yeah, at least write it. Okay.